and we're going to look at binomial. And I'm going to start with exercises. But this is all from module 8. Okay, so this is the set of assignments from module 8. What page? I think it's 5. Sorry, it's page 5. Called practice assignment. What we learn is that if we can identify the variable x, the parameter n, p, and k, what we have is a binomial distribution, and we can solve it using the binomial formula. So let's read the problem. If a fair die is rolled 6 times, the probability of obtaining exactly 1/5 is equal to, so, oh, I forgot to add. So in a binomial, there are 3 characteristics or 3 criteria that have to be met. First, that the phenomena or the experiment that you're looking at or observing has one of 2, or has up to 2 outcomes. One we call a success is the one we're interested in, and the other is called a failure, the one we're not interested in, particularly measuring. So we're going to repeat a process identically from trial to trial. The outcomes are independent. That means that the probability doesn't change from trial to trial of seeing what you're looking for, the success. In this case, reading the problem, we're going to look for those 3 things. So first, it has to be a success or a failure. There are n trials, so we have to find out how many times we repeat the experiment, and that we know the probability of getting what it is we're looking for. That's p. So these are called the parameters. This is the variable, and I'm going to write here the values that it takes, and then we'll talk about what k is. Okay, so how many times do we repeat this rolling of the die?
6.
So we repeat 6 times. So this is a 6. And what are we looking for? Each time. What are we looking for?
The probability of 1 being 5.
Not the probability. We're looking for each time we roll, each of the 6 times. What are we observing? What are we observing for?
To be 5.
We're looking for a 5. A 5. Okay, so we're looking for a 5. Okay, we're looking for a 5 each time. So if we're going to do this 6 times, what's how many 5s can we see? What are the options? Well, we could see 0 5s, we could see 1 5, we could see 2 5s, we could see 3 5s, 4 5s, 5 5s, or 6 5s. Okay, so we're separating each time and then the totality of the times. Once you understand that, you're going to be fine. So there's 6 trials. I can get 0 to 6 5s. What's the probability? What's P? The probability of getting a 5?
1 in 6.
Say it again.
1 in 6.
1 out of 6. And we're going to leave it as a fraction because it is a repeating decimal and we don't want to round that. So just leave it as a fraction. It's fine. We could put that in our calculators. So we have X are the possible outcomes for the variable X. Because we've been able to find N and P, we can say X distributed binomial with N of 6 and a P of 1 over 6. Okay, we could write that because that's how we write. Now the parameters are N and P, which seems weird because we had to do a lot of calculations to find the parameters for normal. So it feels a little bit strange, but they are the parameters because you'll see in the binomial formula, that's all you need to describe the distribution and to estimate probability. So that's why we call them parameters. And they are the population parameters, right? The population characteristics parameters. So right now we're working with the population. All right. So these are the possible outcomes. It's discrete. We can make a list of all the possible outcomes. N is 6, P is 1, 6. Now we're at K. K is the one, the items we're actually looking for out of the possible outcomes. So what is K?
1.
Yes, and you get that from here, right? Well, let me do that again. Right, because it says exactly 1/5. So out of all of these, I don't want to find out the probability of no 5s. I want to find the probability just 1/5. Let me see the chat, sorry. Oh, and there were some outstanding questions from last week too, if anybody has them to give or to make. So K is going to be, I'm going to circle what I want. So I just want this. And that's it. So now with all that information, I can find the probability that X is 1. And by the binomial formula, what I do is I think about all the possible ways of seeing one success out of 6. And what does that refer to? So these are the possible outcomes rolling 6 times. And one success can look like that. The first one's a success and the other one's a failure. So in other words, you get a 5 and then you get another number and a different number than 5 and a different number than 5 and a different, that's what it means. And what's another way of seeing the same thing? It's just a matter of reordering. You're going to just move the S through. Okay, so obviously I see it's going to be 6 possible ways of seeing this outcome. But I wrote them just to prove it, okay? So there's 6 possible ways. In fact, I explain in the videos that this portion, this is called the binomial coefficient. This will always be, if you choose 1, so it's a 6, choose 1 is always going to be the value 6. It'll always be the N. So this is going to be 6. We'll do that in a second. That's what that means. And then I have to multiply because it's independent. I'm going to use the rule of independent events. I can just multiply the probability of a success The probability of a success is, we said 1/6. And I want to see one of those. And a probability of failure is 5/6. And I will see, so this is giving me, it's giving me the probability of each one of these outcomes. Okay, so this is the chance of seeing a success is 1 in 6. And then the chance of seeing a failure is 5/6 times 5/6 times 5/6 times 5/6 times 5/6. That's where that comes from. All right, so then knowing this formula, you shouldn't just be plopping in numbers. You should understand where it comes from. So it's applying the rule of independent events. And there's a pattern when it comes to the binomial distribution, and other distributions have patterns, but this is the pattern for binomial. And all I have to do is find the probability of one of them and then know how many different ways there are to see one success out of 6. Or in other words, 1 success and 5 failures. So I have the probability of one of them, and then I multiply it by how many different ways there are to see it. And that's that. And you can put that in your calculator. So I'll show you that. So I'm going to enter it just as it is. Remember, we have our calculators. I instructed you to put it in order of operations to honor order of operations. So I can just multiply straight through. I can say 6 second function NCR. So that's 6 choose 1, just to be sure. So that will be equal to 6, as I said. Multiply, you can put in 1 divided by 6, and then that's it, because it's a power 1. So let's simplify this before I put it in the calculator. Let's do that. Let's simplify this in the calculator. And this is going to be 6. And this is 1/6. And then this is 5/6 to the 5. But this cancels with that. So all I really have to put into the calculator is 5/6/5. But let me finish what I was doing here for people who are interested and just doing it from here. So you're going to multiply 6 by the inversion of 6. So I take 6 and I use the inverse function to get 1/6. And then I continue to multiply. Now I'm going to have to put this in brackets because otherwise it won't know. It'll do the division. Anyway, it will misapply, I think, the exponent. So 5 divided by 6. Oh, sorry. I wanted to do the bracket. 5, I think I screwed up. Divided by 6 to the power 5. So it doesn't move because it's order of operations. It keeps that bracket still until I put the power 5. And that's the answer. Okay, so I'll do that again. So that's how you would plug it into this calculator, or a calculator that observes order of operations. So 6 second function NCR1 equals times inversion of 6 times bracket 5 divided by 6, close my bracket, but raised to the power 5 is that. And you can do this all with algebra as well, but I'll leave that to you if you want to do it that way. The more calculations you make, like on paper, the greater chance for error. So I'm trying to avoid that. Just entering it into the calculator immediately. So the answer is A. Any questions? So when we're in the binomial section, I always want you to use 4 decimal places, even though I asked just for 2. I prefer I'll say 1/9. I like you to get the habit of keeping 4 decimal places. Any questions about that? Do I need to calculate that again? So to double check what you did, and don't get tied up with the formula, but understand, we have to account for all 6 trials. So those exponents need to sum to 6. And we have to account for all possibilities. So these 2 in here need to sum to 1 because that's P. And that other one is 1 minus P, and they must sum to 1. P is the probability of success. 1 minus P is the probability of failure because they are complementary. Questions? Should I do it again? Are you good? We have more to try anyways. Okay, let's go to the, okay, let's go to, I don't want to do the second one. Well, I guess we'll do it, but it bores me because it's so much in the notes. But okay, let's do the second one because I got to make a point here. So let's read the problem together like we did above and try and find X, N, P, K, and the success. If you can find those, you have a binomial. Did you watch the video of me determining which of several exercises are binomial? Did you watch that? I gave a handout and we're supposed to read them and find which one is a binomial, finding N and P. That should be in the video. I guess we can do that after. Orlando, you saw that? It's in the conferencias. Okay.
Sorry, I have my dog here interrupting me.
Okay.
At least I saw all the videos.
Okay.
Uh,
Okay. All right, so for this one, the probability of observing no fewer than 2 heads in 4 tosses of a coin. So what are we repeatedly doing for this problem?
Tossing the coin.
So 4 tosses, right? So that gives us the repeated trials. There's going to be 4 of them. So I have that. And what's a success for these, for this set of trials? What are we looking for? Each time. Each time.
The
we
head
talk.
side of the coin.
The head?
Side of the coin.
Okay, but what are we looking, which one are we looking for?
Heads.
Head. That's the one is
heads in
mentioned,
each
so
try.
that's what we're gonna write.
Yeah,
Okay,
heads.
head. Okay, so it's head or tail, but we want the head.
Mhm.
And now, so X could be no heads, 1 head, 2 head, 3 head, or 4 heads, because we're gonna try 4 times. What's the probability of a head?
50%.
We can use 0.5 or 1/2, but I'll put 0.5. On each try, the chance of a head is 50%. But over all the trials, which one of these do we want to compute?
2, 3, or 4.
2, 3, and 4.
2, 3, 4.
Right, no fewer than 2. So remember, if you ever get confused, think about money, no fewer than $2, 3 and 4. So you don't need the 2. No fewer than 2. Yeah, you can put 2 in here, right? Did you guys say 2? I think you can
Yeah.
put 2. Yeah, you can
2,
put
3,
2,
and
3, and
4.
4 in this one. Yeah, sorry. Yeah, so it says if it said more than 2, but no fewer than 2. So it could be 2, 3, or 4. All right, so that's what we want. So the K is 2, 3, and 4. So it means because the binomial formula only works for one at a time, it means I have to apply it 3 times to solve this problem. So I have to calculate x equals 2, x equals 3, and x equals 4. So I'm going to repeat what I did before. So I want to look out of the 4, the chance of seeing 2. How many ways are there to see that? Out of 4, the chance of seeing 3, how many ways are there to see that? And out of 4, the chance of seeing all 4, well, how many ways are there to see that? So you can just put it in your calculator and get it, or to understand, let's look at that again to understand. So to see a success, 2 successes out of and 2 failures, that's one way. I could just start to funnel this one through. That's another way. That's another way. And now I can start. So I need more, right? Because now I have to move this S through. So this becomes tedious, right? You don't want to do this. That's why they developed combinatorics or combinations, and they programmed it into Excel, into other calculators and things, because who's going to do this? Just me. Let me do this again. So then this would be, what am I going to do? I'm going to move that one over and repeat what I did there. In general, there should be 6 ways I can do this that are unique. Yes, there's 2 successes, but there's different arrangements of the successes. Okay, so how do I find that? In my calculator, for second function NCR2, or you can put it into Excel if you didn't get the calculator and find the number. You could actually find the entire answer in Excel, which I'll show you later if you're interested. And there's one more. Anyway, and there's one more. There's 6. Okay, so that's how you have to think about that. So this one will be 6. 4, choose 3. How many ways of seeing 3 successes out of 4? In other words, 1 failure. So that's going to end up just being 4, because we're gonna funnel through, or we're gonna move or shift 1 failure through the different positions. So that'll be 4, and this one will be 1. How many ways of there seeing 4 successes out of 4? That's all going to have to be S, 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 and S. So there's only 1. So that's how you see that. Now we're going to put in the probability of success, because we want to have the probability of just one of these. So let's do this one. So that is going to be the success probability. We said was 0.5. So there'll be 2 of those, and that leaves failure. to be 2, remembering that these have to sum to 4 or n, and these have to sum together to make 1. And then we'll continue. And this one is 0.5 with 3 successes, but failures would be 1. And then this would be 4 successes, and failures would be 0. Okay, so let's simplify this before we go to our calculator. That one would just be 1, so we don't have to use it. And this would be 1, so we don't have to calculate anything there. And let's just calculate each of them and sum them up. Okay, the missing one is failure, success, success, failure. Okay. So let me make some room for my answers. So the first one would be 4 second function NCR2 times 0.5 squared times 0.5 squared. Now you should be familiar with these because we calculated these already. So these numbers should seem familiar. I'll just store that. I'll pull that up in a moment. Let's do the second one. 4 second function NCR3 equals, so remember I told you that would be 4 times 0.5 to the 3 times 0.5. And I'll store that in 2. And then the last one will just be 0.5 to the 4 and store that in 3. Okay, so the first one was 0.375. The second one was 0.25. And the third one was 0.0625, sorry. Yeah, because it's essentially, we're always because it's 0.5, it's actually an easier thing to calculate times 4. Yeah. Okay, so then you add those together. That's what you do with them. And that's our answer. Questions about that? Any part of that? Don't be shy. Because I'm here now. So the answer is C.
Yes.
Yes.
Okay, let's do some hard ones now, because those were not hard. I mean, I don't consider them harder ones. Do you want me to give you time to try yourself and then we'll do it? So I want you to try 4, and I want you to try 5 by yourself. Okay, 4 and 5, and give you 5 minutes.
Okay.
Okay.
Because some of them are just too easy. Okay, wait, let me put the time. It's easier. Resume. And I'll pause the video, but remind me to turn it back on because I forget often. So let's get back at, well, I'll give you like 7 minutes. So it's going to be 9:50. All right, I'm back. How'd it go? Did you finish? No? I should have checked if you were still writing. If you still need more time,
Almost.
or you think at least we can do the first one?
Yeah.
How did you do with the first one, number 4?
I didn't get any of the answers in there, so I think I did yeah, I definitely did something wrong.
Okay.
That I think I definitely did.
So these ones just are a little different, but they're really good. I think they're good questions. So let's do it again. X, N, P, K, success. It's so funny. I'm forgetting how to write in English. It always happens. Okay, success. So what did you find so far? Let's read together. African hospitals treating patients who have Lassa fever. 70%, wait, Lassa fever. So that's what they're looking for. Patients with Lassa fever, 70% of patients with this disease die. Each patient lives or dies independently of other patients. There are currently 7 patients with fever. The probability that 6 or less die is. Okay, so first of all, what are we looking for repeatedly? What are we repeatedly looking for?
Patients with Lassa fever.
All the patients have Lassa fever, so that's not it.
The ones who
The patients
who
that die.
The ones that die. It's sad, but yeah, that's what we're looking for. So it's not a happy thing. Success is just what we're looking for. It doesn't imply normative value or anything. Okay. So success is unfortunate death. And so now that you know that, what are the other things? Where can we start? So now, see, you can even get the death out of this because the percentage they give you, 70% of patients with the disease die. So, okay, so everybody has the disease. So really success is death if you have the disease. But since everyone has the disease, I don't have to specify. So death. So 70% would be the probability of death. And N is how many times we're going to look. How many times will we observe looking for death?
7?
7.
Exactly. So it seems weird, but I'm looking at patients is like a trial. Okay, so I'm just looking at 7 patients, 7 trials. So the possibilities are 0 deaths, 1 death, 2 deaths, 3 deaths, 4 deaths, 5, 6, or 7 deaths. Now, which one of those overall am I interested in? That'll give me my special K, you know, like the cereal, right? That's how I make you remember that. So what is the special K? Which one of these are we interested in?
Less than 6.
6 patients or less. So we are going to calculate 6 patients or less, all those probabilities.
Sorry.
Right. Or what can we do? What's an alternative than adding all those together?
1 minus
The probability of 7.
7.
Not just the probability of 7 though, 1 minus the
1
probability.
minus.
Yeah,
Right?
my 1 minus, yes.
Yeah, don't forget that because that's where you're going to go wrong. And even the questions here are tricking students that made a mistake or it's catching them. So you do that or 1 minus the probability of X equals 7. So it's all these probabilities that sum or this one. So this seems more manageable, more efficient. So let's do that one. But don't forget the 1 minus. So we're going to write the whole thing 1 minus probability X equals 7. And that's 1 minus. So we're going to put 7, choose 7. So there's 7 ways. So it's only one, right? There's only one way of seeing all that all of them die. And so what's the probability of death? It's 0.7. and I want to see 7, well, I don't want to, but that's what I'm measuring, that all 7 die. If they don't die, the probability is 30% that they don't die, but I'm interested in 7 dying, so that's a 0. So these ones make 7, and these 2 make 1. Because the first one is P and the other one is 1 minus P. That makes 1. So to simplify this, this will just be 1 because there's only one way. You can check on your calculators. This one will be 1 because anything to the power 0 is 1. So all you're doing is raising 0.7 to the power 7. And subtracting it from 1. So it's just 0.7 to the power 7 is 0.08. You see how you think you're done with 8%, but you're not done yet. Because you have to subtract it from 1. So I take 4 decimals, and then I subtract, and I get 0.9176, or 92%. Does anyone want to see me make any other calculations? So the answer is E. And I'm using the basic rounding rules. I didn't do anything special. Yeah. It's tricky because you, between 91 and 92. I picked 92. Okay. All right. So do you need more time for the second one? You're ready for the next one? So what did you get for question 5? Okay, so a few of you did question 5. All right, let me try it. Okay, so what are we looking for in this problem? Four patients with SARS in a Toronto hospital who are monitored by 2 staff members. So there are 4 patients with SARS. Suppose the probability at any one time of a patient requiring emergency attention by a staff is 30%. So they're giving you here the percentage about requiring emergency attention. And then at the bottom, they ask you to find what is the probability at any one time there's not sufficient staff to attend to all emergencies. So these are related, right? So I want to know about emergencies, requiring emergency attention. So what is my success? What am I looking for?
Patient requires attention.
Exactly. The patient requires attention. Patient requires attention, emergency attention. Or another thing is just to say there's an emergency. How many times will we look for the success? In other words, what is
Four.
N? We're gonna look
Four.
Four
Four.
times, right? And what's the probability of a success?
0.3.
0.3. So the possibilities are no successes, 1 success, 2, 3, or 4. Now, which of these am I interested in? For that, I go to the last expression. What is the probability at any one time there will not be sufficient staff? How will I define that? How will that be defined in this?
Anything
this
above 2.
scenario?
Above. Yeah.
3 or 4.
Above. So
So the reason is
Yes.
because there are only 2 staff members.
Mhm.
So there's only 2 staff. So I guess there's a implicit assumption here that you assume each patient or each emergency requires only 1 staff member. All right. So in that sense, then if 2 are being, if there's 2 emergencies, we lose 2 staff members. So the only time we're going to be in trouble or have insufficient staff will be 3 or 4 emergencies. So I think it's important to say this assumption because it's kind of, you're making that assumption when you do this calculation otherwise. All right, so now we're going to calculate then for 3 and 4. Probability X equals 3, probability X equals 4, and we're going to sum them. So the number of ways of seeing 3 out of 4 successes and the number of ways of seeing 4 out of 4 successes multiplied by the probability of a success, which is 0.3 to 3 successes, and that leaves 1 failure at, so the probability of failure is 70%, and there's only 1 of those. Then I'm going to do this next one, 4 successes, and that leaves 0.6 is the probability of failure, and there's none of those. So simplifying, this is a 1, this is a 1, this is a 4, and now you can easily calculate one at a time and add them together. So the top one is 4 times 0.3 to the 3 times 0.7. So I get 0.0756, and I add it to 0.4 to the 4. 0.4 to the 4 is 0.0256, and I add 0.0756, and I get, oh, a different number. What did I do wrong? Let me do that again. 4 times 0.4 times 0.3 to the power 3 times 0.7 is 0.0576, and 0.4 to the 4 equals, oops, 0.4 to the 4 equals, that's that. 0.4
0.3.
to the 4.
It's 0.3 and 0.7, Professor, right? In
Oh, I don't know where I copied those numbers from. That's so weird. Thank
0.3.
you. I don't know
Point-
what I was doing,
Okay.
sorry.
0.3 and 0.7.
I don't know why I did that. Okay, let's fix that. It's still 0.3. It's very weird. And this is 0.7. Let me open it up again. I don't know what I was thinking. So this is still 0.3, this is still 0.7. And that second one then is 0.3 to the power 4. Point 3 to the power 4. And then I add 0.0756 is my answer.
Yeah.
Sorry, I don't know. Whatever. I don't know what I was thinking. I'll have to watch the video, see what happened. So the answer is B. Okay, so I think I've done enough. You need to practice. Sorry for the confusion. I think because I was trying to give the example and my mind was drifting. You can also do this in Excel. Have you guys seen me explain the Excel?
Yes, please.
Yes.
But did you try? I mean, I'm pretty sure I showed it in the videos. You don't remember or you didn't see it?
I saw it in the video again.
Yeah, in the conferencia.
Okay, so I'll do it here.
Yeah, the video says that we need to be careful with the cumulative, whether we use 0 or 1.
Sorry, I don't know. What do you mean?
No, that when you use Excel, we need to be careful with what is the question that we're being asked, because if we put cumulative 0 or
Oh,
1,
yeah.
it would change.
Yeah. So, all right. So you can pick functions, right, using the equal sign, right? So look at all the different binomial combinations. So you can make calculations. The binomial distribution here, it prompts you for the number that you're interested in. So that will be your special K, the trials and the probability. So it does K, N, and P. And then you have to decide if you just want the value or you want the cumulative, and that's every value before it. So let's say we did the one with 6. Let's go to number 4, right, with African Hospital and Lassa Fever. And we wanted to calculate for 6 or less with 7 trials, and the probability of death is 0.7, I'm going to say, yes, I want cumulative, and that will give me all the probabilities summed from 0 to 6. And there's the answer that we got at the end, the 91.76 or 92%. All right, let me show you that. So that's the formula to get that answer from the Lassa fever example. So let's say you want to make the entire distribution. You don't want to just get an answer. You want to see the distribution. We can do that. What I can do is put x equals little x here. And using the binomial formula. Sorry, what's happening? So I want to use just the binomial function, binomial distribution. And I'm going to start with 0. No, sorry, that's not what I want to do. Hold on. What I want to do first is make the x's, and then I'll do this. So those would be the x's: 0, 1, 2, 3, 4, 5, 6, and 7. And then I want to do the probabilities. And that's going to be binomial distribution. And I can put 0 in here and say 7 trials and probability is 0.7 of death. And then say not cumulative. I just want the value itself. And I could actually just not put 0, but put B. I can put the cell B2. So it puts 0 in there for me. So it's using this thing here. And then if I just copy it down, I can get all the probabilities. So this is, I'll copy them. I'll just show you what I did. Okay, but I wrote B2 so that it would use this one here. Okay. And then I copied it all the way down. And that one would use, because it uses the relative association, it's going to take the number that's in that column.
Professor, I have a question.
Yeah.
What about if we are asked to determine 5, 6, and 7? Is there a way to do it in Excel without any manual calculation afterwards?
Hold on, let me finish this.
Okay.
Okay, so I just changed the formula so I could use this here, but Excel is smart and it just does it automatically. If I copy, it knows I want, what happened here? It knows what I want. Any questions about that? So these should sum to 1. And you have the entire distribution, and you see the distribution it's not symmetric. It's small and then it gets bigger and then it goes up and then it goes down, and it's not symmetric. It looks kind of skewish. These are just a spike drawing if you were to draw this, because it's a discrete distribution. Okay, Orlando, your question?
Yeah. What about if we are asked to determine 5, 6, or 7? Is there a way to do it automatically in Excel, or we calculate each one separately and then sum them up?
Yeah, it's just, I don't know any other way. You just got to do this. If you look at the different functions, there's maybe here
It's
distribution range.
maybe the range.
I don't know. Let's try. Let's do 5, 6, 7. Well, actually, no, let's just do the same question. So 0 to 6, right? So trials would be 7. Probability is 0.7. Number S and number S. I guess you can just put all the numbers in that you want. Okay. That's what they're trying to say there, I think. So you will just do 5, 6, and 7, or let's do the one so to check the answer. Then I have to write all of them. 0, 1, 2, 3, 4, 5, 6. Didn't like it. I think it wants the range. So I can just put 2 numbers. Let's just put 0 and 6, see if that works. There you go.
That's nice.
Yeah, well, thanks for the question. See, I didn't even know. So I did a range, but like you said, you can just get 5, 6, 7 using this function here.
Thank you.
Sure. Any other questions? So notice there's all those other functions too. They have, oh, look at all these functions. They have lots of functions. So I don't even know those. This is the inverse binomial. So this is if you have the percentage, it can tell you the X. Interesting. This is a combination. You should be able to do 5 choose 6 here. Yeah. So 4, like we know 6 choose, no, 4 choose 2 should be 6. So that's also in Excel. Combinations, like the function on your calculator.
The NCR.
And that's the NCR. Yeah. And there's a lot. There's also the hypergeometric, the Poisson. Sorry, let's try Poisson. See if it works. Poisson distribution. Hypergeometric. Hypergeometric is there. And you have to put all those parameters in. Okay, so it's all at your fingertips. All this stuff has been there for you all this time, all these years, and you never knew. But it's all there. So the equivalent, 30 years ago, before computers were ubiquitous in everybody's office or home, there were books of these tables made for different distributions that professionals used, but now it's all programmed into Excel and some calculators. You just need to know the parameters and how to apply them. So I focus on the binomial to make you really good at binomial, and then you'll feel confident to tackle other distributions. And I gave you some experience with the other kinds of distributions. Are we done with this? We're going to talk about SDS. So there's just a bunch of problems. On the platform, there's a bunch of problems that I've given as well. Let me open the platform. Someone asked me to look at the homework. Mm, mm, mm. Okay, so this is the platform, and you have here in 8 in the conferences, and then I have some document here with the binomial distribution, I guess, that I reviewed in the class. I can't open it easy enough. Oh, and I was just showing them. So that goes with the video, just if you wanted that. Okay, and then homework solutions. Now this solution set is a complete set of a lot of problems, but you should try them without reading them. Try them on your own, just like I did in class, and then just confirm here for the ones that you got wrong. Then there's 2 practice assignments. There's quizzes. Got a lot of stuff here. And I actually solved quiz 8.1.2 here because I think people had questions. All right, so homework. Remember also the homework is at the top. I have the solutions to all the homework that I put. Where did I put it? Homework solutions, maybe in the first module. Right here, all homework solutions. This is in module 1. Maybe I should move it. So that's the solutions for all the homework exercises there. Okay. Did you know that? I'm sure I mentioned it. Where should I move it? I should move it. I guess I can put it up here. Let me stop for a second. I'll duplicate it and move a copy up. All right, you should be able to see it. Put it. It's a long trip up because I have a lot of documents you can't see in there. All right, there you go. Okay, so I moved it here. Can't miss it. All right, so you had questions about the homework. Let me see the chat. All right, bin 18 and 20. Bin 18 and bin 20. Okay. And then 15. Okay, and then 3 and 20. 3. Okay. Yamelis, do you know how to do 3 now?
Yeah.
Yeah? That's
Yeah.
good news. Okay, good. Okay, so I can skip that one. Let's look at 15. Okay, okay, let me share that. Make sure you're seeing that. Okay. When independently assessing a patient's eye, 2 doctors are known to agree 90% of the time. If they assess 6 patients, the chance they will agree exactly 4 times is, okay, so you need to find X and PK for this. So what's the success? How will we define the success? What are we repeatedly looking for in one word?
That they will agree.
The doctors agree.
Agreement, right? So agreement is the success. Okay, and what's the chance that they agree?
90.
90%.
90%.
Right. If they assess 6 patients, the chance they will agree 4 times. Okay, so 6 choose 4. That looks good so far. 0.9 successes. That's the probability of success, and 4 successes. That leaves 0.1 for failures, and there's only 2 left. So A looks good. B is missing the second part, the failures.
Mhm.
C is missing the binomial coefficient. D is upside down. And so the answer is A. Is that good?
Yeah.
Good. Good. So you're better with reading this now, what this is?
Very much better.
Much better.
Yeah.
Good. Good. Yeah, it's really, once you get it, it's very easy. It's very easy, but you do need to get it. Okay, 15. Let's look at 8. Not 8, sorry, 18. And then 20. Lots of 20s. The probability is 0.4 that a divorced person will remarry within 3 years. In a group of 10 divorced persons, let X be the number of divorced persons who remarry within 3 years. Oh, okay. So what are we repeatedly looking for?
Divorces.
No, the remarry.
Okay, so yeah, this is like tricky, right? Yeah, you want to look for the marrying, but we're looking only at divorced people. So don't
Oh.
get tricked, but you're looking at the population of divorced people and you're looking that they will remarry. So remarry is a success. It's very positive, or maybe not, I don't know. But we're looking for that, okay? Remarry, the probability of 0.4 that a divorced person will remarry within 3 years. It's very specific. Remarry within 3 years is the success.
Okay.
In a group of 10, so that's the N, let X be the number of divorced persons who remarry. So let me write this one down. Let me do this one on paper or on my iPad. So I'm gonna write it out and then I'll show you. All right, so what we have is we're going to look how many times? 10, right?
Yes.
Yeah.
We're going to look at 10 divorced people and the chance that they will remarry in 3 years is 40%. So the possibilities are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And what are we in particular interested in? The probability that between 2 and 5 inclusive will remarry. So I mark them. So you just got to translate into what we did the question, right? So 2, 3, 4, and 5 inclusive, because it writes so now our X is a binomial, it's a binomial variable and it's discrete, so it can take on the equal sign. So it can be all of these. So that's what you want to find. And you got to do it. So you could do it with Excel. You can do it one at a time and add them up. That's up to you. 2, 3, 4, 5. Do you want me to do it? You want me to do it in Excel? Are you going to do it for me? you guys do it? You guys try it and then take some time, try that. And see which one is the answer, and then we'll do 20. Let me see if there's other questions. I think that was it. So we still have an hour. We can do some problems from the sampling distribution as well. So you do need to come prepared to these meetings, right? To get the most out of it, because I'm not going to go from 0, but you need to go back. If you didn't watch the videos, go back and watch them, and this should all fall into place. Sorry, I did it again. So it's always the same pattern. So if there's 2 successes, then there's 8 failures. If there are 3 successes, then there's 7 failures. If there are 4 successes, then there's 6 failures. If there's 5 successes, there's 5 failures. Any questions about the formula? So I hope you see the pattern now. So it's I didn't write it once today, but I'll write it now. So hopefully this makes more sense now. These sum to 1 and these sum to n. And notice all you need for the formula are n and p to solve for a specific k. You need to know the k, of course.
Professor, I have a question.
Sure.
In that problem, I thought we could use probability of x equals 5 minus the probability of x equal 2, but I don't know if it
Okay, so what does this
Yes.
mean is the issue, right? What does this mean? No, that's not it. So you were thinking of the normal, but this means yeah. So if you took the probability, if you did cumulative, if you use the cumulative formula and you said the probability of x equals 5 cumulative minus the probability x equals 2. Are you following what I'm saying? So this is really what it means, right? But if you wanted to do something subtraction like you did in the normal distribution, you should take off everything before probability x less than 2. You want to take that off of probability x greater than 5. That would be something you could do. So then you just get the in between. Because this would be, if you interpret it like cumulative, then everything greater than 5 no, I still don't think that works, because then that would be all the ones greater. No, that doesn't make sense. No, this is the interpretation, but I see what you're thinking. But that's what it means. It means the sum of those. It means the sum of those. So you could do
Okay,
it in
thank you.
Excel with the range 2 to 5. That will give you the answer, or the long way, calculating one at a time. So what we were discussing is does not mean probability X. And it's specifically because it's discrete. If you did this in Excel, You'd have to use the cumulative distribution. We can check that. Because doing it this way, it won't make any sense. You'd have to add all those up and then subtract those. That's a lot of work. Okay, did you guys finish? So Victoria tells me it's 0.1209, 0.2150, 0.2508, and 0.2007. And it makes 0.7874. And let's see, I'm going to do that in Excel as well to confirm. Okay, so I'll show you what I did here in Excel. Now, what in the world do we use this for, right? So binomial distribution is really at the heart of sampling theory. And you'll get that, you'll see all that come together when you do sampling distribution of a statistic and then get into inference, which is our last module. So it's all connected. So this is the distribution with n equals, actually, let me get this one out. And here you're supposed to put 0. Okay, so that's what I did with 0.4 and not cumulative, right? So that's the distribution, and we would have to add, these are the ones that we had here. And we had to sum those. And that's what we got, 7874. So that's the answer there. So if you did this cumulative, the question is, will you get the same answer? So this is not cumulative. That's the distribution. This gives the distribution. And it just shows you for each value. But if you want cumulative, it's everything before it, including it. So I'll just copy this. And all I'm going to change is this to a 1. And the cumulative one ends up with 1 at the end because it's adding as it's going. So if I take 5 minus 2, I don't think it's going to work. I think I have to take 6. Is that going to work? Yeah, see, that doesn't work. You have to go, you have to get these, you have to include those. So you got to take 6 minus what's less than 2 is 1. No, that won't work either. I think it's 6 minus 2. Anyway, it's confusing, right? That doesn't work either. So I don't know. Why doesn't that work? So make me sure I did this right. Let's be sure. So that's 0. This is 1. So it's because it's discrete and not continuous. I do have a discussion about continuity correction that I asked you to see. It's not going to be on the final, but it's interesting. Because this is 5 and everything before it. This is 2 and everything before it. So I think you have to do, if you want to do subtraction, I think you have to take this one minus this one minus this one. And that will work. Nope. That didn't work. No, 6. Sorry. I'm gonna take this one. Okay, this is the last try. Oh, doesn't work. I don't know. So anyway, just, yeah, if you need to add them, just add them up, or you can use the range function in Excel, which was, remember, binomial distribution range, and you just put in there 2 to 5 and it'll take care of it for you. Let's see. So I want the trials are first, it tells you, and then you put in the probability, which is 0.4, and then you put the range 2 to 5, and that's it. And it should give us the right answer. It does. Any questions? Are you guys following what I'm trying to do? I'm just trying to see if this can be subtracted, but it's not so clear. You have to calculate one at a time and add them. So the instinct to do this like you do the normal, just got to be careful because it's a discrete distribution, not a continuous. Let's see. Comments. Okay, so that was 18. Let's do 20. Can I stop showing that? Let's do 20. Oh, sorry, let me show you the question. All right. About 20% of the adult residents of Los Angeles are Black. 12 jurors are to be selected for a double murder trial. The expected number of Black jurors and the probability of at least 6 Black jurors are respectively. Okay, so let's see. Is this binomial? If so, what's X, N, P, K? So what are we looking at? We're looking at the 12 jurors. And so that's N. And we're checking to see if they are black, right? Expected black jurors. And the chance of that is 0.2.
Yeah.
So out of the 12, 0, 1, 2, 3, 4, 5, 6, 7. I'll show you my tablet in a moment. 8, 9, 10. 11, 12. We have to answer 2 questions. The expected number of black jurors. And the probability of at least 6 black jurors. At least 6. Expected number. Oh, I see the confusion. I know what's going on. All right, so let me put let me write the questions down. You see my iPad? So this is what I have so far. It's up to 12. N is 12, P is 0.2, and what is the K? That's the question. So the first part is asking for the expected number of black jurors. The second part is asking for the probability at least 6. Let's do this one first because this falls into what we've been doing so far. So at least 6 means all of those. So you can do that in Excel, or you can do it one by one, but that's what you want to compute. All right. The expected number of black jurors, if you continue into sampling distribution of a statistic, I talk about the mean of the binomial. Did anybody read that yet? What is the expected value for a binomial? So if X is binomial and P, the mean is what? So this is a distribution. We just saw several distributions. Where's the balancing point of the distribution? So I solve that. I actually do it theoretically and I solve for it and I show you. And I also use a very simple analogy. I say, okay, let's say a basketball player has a probability of 80% of dunking, or not dunking, but getting a free throw. Okay, so he gets it in the basket. So he shoots a free throw 80% of the time. He gets it in. If he tries 10 times, what do you expect? How many are going to go in? Okay, so he's going to get 8, you expect, because all you've done is you've taken each chance. It's going to be 80% times 10 chances. And so he's going to get 8 baskets. So all you did, and the rule is that the mean is just N times P. And the standard deviation, I do a solution, I actually solve it, that the standard deviation is n times p times 1 minus p square root. So those are actually the formulas that you need to know. So now you can answer the question, what's the expected number of black jurors? If the chance is 20% and you're going to take 12 jurors, what's n times p?
$2.4.
2.4. Is that an option? Yes, 2.4. And then the probability that at least 6 are black. We can go to Excel and do that. All right, so this comes out of the sampling distribution of a statistic information. So in unit 5, sorry, not unit 5, in modules 8 and module 9, I have a formula sheet at the end, and I've used that a lot to, I asked you to like print it and keep it with you for the next few weeks, because that pretty much is what you need to know for the exam. And you can, you know, the exam is virtually, you can use all your resources. And I use that formula sheet. And on that formula sheet, let me show you in the notes. So at the very end, I have this, and you see what it says at the top. It starts with module 8. If X has a binomial distribution with parameters n and p, then X has a mean NP and a standard deviation NP 1 minus p square root. So it's right there. And then this is the binomial formula for each K. And then I start talking about this distribution being approximately normal under certain conditions. And that's what I talk about in SDS section of module 8. So okay, so it's right here. So that's how you knew that. That's how you would solve that. Are you guys good for the rest? Can you do the 6, at least 6 you can calculate in Excel? I can do it as well. So we're going to make, I'll just copy this one that I already did. I can do at least 6. So I could do subtract off of 1 from 0 to 5, or I could add them individually. So I'll do the not cumulative. I'm going to copy this in a clean area. And I want to put in here B35, which is 0. It's going to be 12. And the new probability is 0.2. And I have to add 2 more. And I'm going to get rid of this. And there you go. So now I want to sum from 6 till 12, right? That should be the answer. Is that an option?
Yes.
The answer is B.
Number
Let-
B.
Letter
Digo, letter
B.
B.
Professor,
Letter B.
Yes.
I have a doubt.
Yeah.
It says at least 6.
Yeah.
Why we are including the 6 in in the calculation.
At least 6. So if you have at least $6, you could have $6. Right? So at least 6. At least 6 means 6 or more.
6 or more. Okay. Thank you.
Yeah. If you have issues with the interpretation, please let me know. So at least 6 is this. How would you say it in Spanish? Por lo
Por lo
menos
menos 6.
6. Yeah.
También sí.
Is there an error from 9 to 12 with the?
No, this
No.
means 5, because it cannot put all the numbers down, it just uses exponential or scientific notation. So it means 5.67 times
It's
10 to the power of -5. That's what it means.
so it's
Not an error.
it's almost 0, right?
It's going very small. Yeah. If you say, so from here, I'm going to say 0.000 is 0. That's what I say, or I say something like, oh, I gotta wait. 0.0000 is 0 for me, right? So 0.00001 is going to be a 0 because I'm going to stop at 4 decimals. 0.00005 will be not 0. It will round to 0.0001.
So if we do this manually, we cannot get the number, right?
This one, yeah, you could get it. You'll come like that. But this is just like a 0. But the thing is, since you're adding up so many, you don't want to round them yet. You only round at the end.
Okay.
Okay, because this is like a 0, but it's not so 0. If I add like these numbers together, it's going to be higher and higher. So I can't just make them 0. I have to add them all up, because if I just sum these ones, it's not going to be the same answer, probably. It's a little bit different, you see? To 4 decimal places, it's off by 1. So you got to keep them. You got to keep all of those till you're done. So basically it writes it like that because it can't put all the zeros in here unless I expand the decimals, and it won't be a problem. So if I do that, whoops, which way do I go? Let's see. It'll get rid of it. There, you see? So if I allow for more decimals, I lose that function. You can just expand with this here. You can see the numbers better. It takes liberties and does what it wants. Excel and software does too. You just need to know what they're telling you. All right. Okay, you guys learned a lot. 11 o'clock.
Yep.
Yeah.
A lot more than you wanted to know, but yes, everything, this can all be solved in Excel. I can't do that in the classroom, but with an online course, you can. What I'm trying to say is, if this course was in class and the exams were in class, I wouldn't be able to do this. But because we're virtual, teaching you the binomials in the Excel, you can do a lot with Excel. And it's meaningful. You can see the whole distribution. It's nice. And this all should sum to 1. See? All right. So I answered all the questions. Should we do something with the sampling distribution before we go? It sounds like you didn't get that far. Is it possible?
No.
No. Just
Okay.
binomial.
So do you want me to just stop then? We can just stop.
Yeah.
Anyone want me to keep talking? We can just stop it. And then next week is just sampling distribution. The whole thing should be done. I already put an assignment, but you have until not this Tuesday, but the next Tuesday to finish it. So it has a little bit of binomial and sampling distribution in it. So yeah, work ahead this weekend and finish that. and we're in good time. We're in very good time. And then after next week, we start on inference, and we have a few weeks doing inference, and the course is done. And it all comes together. All right. So if there's gaps, let me know if there's any gaps with the sampling distribution material. Next week, work really hard to get me all your questions, and we'll finish module 8. Work with print the formula sheet at the end and keep it beside you, because I will continue to reference it. I'll reference it constantly from now on. So keep it with you. Right. So should I say, we're good? No one, everybody's ready to go? All right. All right. So bye, Vanessa. I know you're waiting for the grades to be posted. I'm sorry. Next week. As I'm working on a big project. I'm working on a big project, and we're actually filming a documentary. So I'm going to finish filming mostly this weekend, and then I'll have more time to dedicate to get those grades up. But I have all the information for the grading, and you'll be assured you'll get that before the test. Okay. Bye.
Right.
Thank you.
Bye-bye.
Bye.
Bye, thank you.
Thank you. Bye.
Bye.